Hello and welcome to this video on processors again. I wanted to go through the looks and the benchmarking of these i9s and i7s and the Ryzens and all that sort of stuff. So I just quickly Googled this and thought this was kind of a cool way of showing you the difference, I suppose, between the i9s and i7s, etc. You can see this is basically just saying the same. Well, an i9 is more powerful than an i7, and i7 is more powerful than an i5. And you can see here that the i5 10600K is more powerful than the 10400, right? So within i5s, we also have a 10 series, that would be the 10th generation, and then some number after that, so some 3-digit number after that. So the 10700K, you also can have like HK and also you have a couple of letters at the end, and they again mean different things. It's a bit out of scope for this, so we won't go through them. But effectively, there are many different types of i5s as well. But in general, you can see that any type of i5, or at least the 10th generation i5s, are faster than the i3s and they're slower than the i7s, right? So this was a neat way of showing you. Now, I'd like to show you, perhaps, if we can get a physical picture of what they look like. These are the boxes they come in. So they like to show you these kind of cool boxes. I think this is a good picture of what a CPU actually looks like. I tell a lie, this isn't what a CPU looks like. It is a CPU, and it's an i900 special edition running 5 gigahertz on all cores, which we'll go through in a second. But that's that's 5 billion calculations per second. That's a pretty powerful CPU. That's a very interesting thing. I wouldn't mind one of those myself. This is a good picture of an i9 actually there. So what's happening here is you can see, we can see this picture. We can see there's a metal ring outside. Now this metal plate is actually like a heatsink effectively. So that's not the CPU. The CPU is basically a small thing inside this. This is the metal plate to take the heat out of the CPU, and this gets attached. Usually you would put a cover over this. You'd put some thermal paste on it, so literally like a sticky glue looking thing on top of that, and it transfers the heat to something that's like a fan or a water cooling system, or however you want to get rid of the heat. So metal pipes effectively is what you would be touching metal on metal to transfer the heat over. But the CPU is inside. I'm not too sure exactly how big the CPU is on this CPU, because this entire thing technically isn't the CPU. The CPU will be inside here somewhere. Now this chipboard here, this green thing behind, is the entire size of it, and it'll have some connections on the other side. I'll show you some connections in a second on the other side of this. The interesting thing here is that we have several things that build up to the CPU. Here's another picture of it on the other side. So as you can see there, that it's got a, let me just try and scroll in. No, let me open this up then. So as we can see here, there's like these kind of pins. Yes, thank you. Sorry about this. Command 0. Sorry, I was just zooming in. I'll just open up the picture in a separate open image in a new tab. Right, sorry. There you go. So as you can see here, there's loads of these pins, and these pins are what goes into the motherboard, which we'll talk about next. But these pins are effectively the socket. Now, I haven't spoken too much about the differences in types of sockets, but effectively they're not all this shape, right? They're not all this size. They might be rectangular, they might be other things. So if I just flick to here a second, this one might be like this, as you could see, and it might look like this, and it had all of the bits in the middle. Actually, there was a gap in that one. You might get one that's this shape. Now this socket might be called a I don't know, an AM4 socket, and this might not be an AM4. It might be some other socket effectively, and they look slightly different, right? These are the things that are going into that you just click into place effectively, or place down. So let me go back to this, and these pins are effectively just getting through to the motherboard. They're the things that are talking to the other components on the computer, so the memory and all that sort of stuff. It's how it's connected. But the pins themselves, again, they're not the CPU. They're not the thing that's doing the processing. They're the thing that's getting in the data for the processing. So here we have not the CPU, and I haven't actually shown you a CPU yet. I want to make this very clear that this entire thing itself is a CPU. But the CPU is inside. The central processing unit, the thing that does the computation, is inside this case. So they're very hardy, by the way. When I was building my last computer, really annoying. These things stick out here. So they're actually physically, they're pins that are physically sticking out. And they're very delicate. And I forgot to put my CPU in properly, and I bent the pins, and the CPU was 600 pound CPU, and I'd bent the pins on it, which I wasn't too happy about, and I managed to luckily get a credit card in between here and just straighten them out with my phone camera magnified in 8 times, because I couldn't find my magnifying glass anywhere. So yeah, these are pins that get connected into the boards, and they're very delicate. When we have a look at the video of how to build something yourself, we will definitely look into how to be careful when we insert a CPU into the slot. So that's an Intel one. I should get away from the Intel ones a little bit. In fact, there's a good picture in. Yep. There's a good picture anyway. I don't want to spend too much time. That's it set in place in an actual motherboard here. That's the motherboard background. So let's have a look at what a Threadripper looks like. These are insanely fast, and you can see that the size of them. I can't. Which one? 2950X. So that's a relatively old one, but I think this is a good picture to demonstrate exactly the size difference. Remember I said the CPU is probably the size of some phones. Okay, it was a bit overkill to say that it was some size of some phones, but you can appreciate that they're pretty big, right? You couldn't fit one of those into a phone. This here is a normal size CPU. So this is probably your i5s or your i7s or something like that. And this is looks like is it a dollar coin or something? I'm not too sure what that is. I can't see it properly on that screen, but it's a coin anyway. It gives you a perspective idea. So again, same principle. We've got the Threadrippers that are effectively there's the box that it comes in. We've got a Threadripper that and the outside of it is a heatsink, and we have to plug it in, etc., etc. There'll be a different socket. We'll talk about sockets when we're looking at motherboards later on. But anyway, that's a Threadripper. I wanted to show you this, and let me just see if I can show you a quick ARM processor. ARM processors here are a little bit smaller. But they're all the same looking thing, right? They need there's the Cortex thing, so that's an ARM. They're effectively all look the same, and we don't really know what they are. That looks like it's an Arduino or a Raspberry Pi or something, and we don't know what they are. We don't know which one they are given the device. It doesn't make a difference. I'm not saying that every single tablet has an ARM processor in it, but it most likely does. It probably won't be an i7 or an i9 or you can appreciate that the Threadripper is quite big. Probably won't be a Threadripper type thing. So I'll cut the video off there, and I'll see you in the next tutorial. We can cover the last bits of CPUs, and I'm hoping that things are sort of meshing together and you can appreciate what we've gone through so far.